I would definitely add this definition to my notes. A quadratic function, this is really important to understand, is any function that can be written in standard form, and this is our standard form. If we think back to standard form in chapter, what was that, 6 for polynomials, standard form was putting the highest degree first down to the constant. Well, we recognize this from factoring, I hope, so we know that C is always your constant and A and B are coefficients. Specifically, A is always the coefficient of x squared, B is always the coefficient of x to the first power. So some examples of quadratic functions and some non-examples of quadratic functions. So, y equals 3x squared plus 2x minus 1. That is quadratic because it meets the definition of having a highest degree of 2. Y equals negative x squared. Even something this simple, it's an example because it still, once again, meets the requirement of having a degree 2. Doesn't matter if a quadratic's a trinomial or a monomial or a binomial. It's all good, and it's going to be a quadratic if it has a power of 2. Non-examples. Y equals 3x plus 1. That's a linear function. It has a degree of 1. Function notation, f of x equals x to the third power. That's a cubic function. So anything outside of the realm of highest power of 2 is not going to be a quadratic.